Okay, here's another example problem where I'm showing you a graph of a sine wave, and I'm asking you to find the period and the frequency based on the labels on the time axis. And in the problem statement here, it says that the horizontal axis is given in milliseconds. So I'm going to go ahead and label that as time with units of milliseconds. And this one, what I'm going to do is I'm going to go now and count periods and see if I can find, if I look at one period here, it looks like it's landing somewhere between 5 and 10 milliseconds. I don't know exactly what it is, and I guess I could estimate it, but I'm going to go ahead and say, you know what, if I do 1.5 periods, it lands right on 10 milliseconds. Similarly, if I do 3 periods, 1, 2, 3, it appears to land exactly on 20 milliseconds. So let's go ahead and use those values and say that the period by inspection is 3 periods, is 20 milliseconds per 3 cycles. Okay? And 20 thirds is 6.67. And this has units of milliseconds because I plugged units of milliseconds into the equation here. And so the period is 6.67 milliseconds. You can use your calculator if you need to calculate 20 thirds using a calculator. 6.67 is 6 2/3, which is 18 plus 2, or 20 thirds. And 6 2/3 is 20 thirds, and 20 thirds is exactly what we've got here. So that makes sense. To calculate the frequency, we invert the period. The frequency is 1 over the period. And I'm going to go ahead and plug in units of seconds here. I'm going to go ahead and erase some of this. And I'm going to go 1 divided by 6.67 times 10 to the minus 3. And if you plug that in on your calculator, you're going to get 150 hertz coming out of this. Make sure you can do that calculation. Alternatively, you can say the frequency is 1 over the period, which is the inverse of this quantity, which is 3/20, which is 0.15, and with a milli in the numerator, it becomes a kilo in the numerator, and so 0.15 times 10 to the third gives me 150 hertz is another way of looking at it. And the sanity check on this one is that this is approximately 100 hertz, let's say, and at 100 hertz we have 100 cycles per second, and that means the period should be something like 10 milliseconds, because 10 milliseconds is 1/100th of a second. And indeed, we have, in 10 milliseconds, we just have 1.5 cycles, so it's somewhat close to 1. It's a little bit more than that, and that's why we have a little bit higher frequency than 100 hertz. Okay, hope this helps.